At the far end of our solar system, Pluto is surrounded by many cold celestial bodies and space rocks in the Kuiper Belt, a large region beyond Neptune. When it became the ninth planet, Pluto took its name from the Roman god of the underworld. However, in 2006, Pluto saw a major reclassification of its planetary power, reflecting a growing understanding of our wider universe. Current interest in our solar system shows a diverse mix of celestial bodies, including space rocks, minor planets, and the 8 normal planets. Throughout human history, our understanding of these physical bodies has grown exponentially, with deeper insights into their structure and behavior, painting a very different picture of our environment. Galactic. Even as our knowledge grows, our own planet continues to be enthralled with exploration and discovery. The James Webb Space Telescope, the pinnacle of modern astronomical progress, is poised to unravel some of these pending mysteries, including those about Pluto. Despite its small size and unusual appearance, Pluto holds a special place in the hearts of many. The classification in 2006 caused a strong public reaction, showing the deep human connection with this distant body. For an object to be considered a planet, it must meet 3 main criteria: orbit the Sun, have enough mass to take on a spherical shape due to gravity, and eliminate orbiting debris. Unfortunately, Pluto, with its erratic orbit, does not meet these standards. The term planet has undergone many interesting developments throughout the history of the universe. At first, it included all the major celestial bodies visible in the sky, including the moons and asteroids. The discovery of Pluto in the 1930s by American astronomer Clyde Tombaugh excited the world, but subsequent discoveries of similar-sized objects in the region cast doubt on the planet. Of particular concern is Professor Mike Brown's landmark discovery of Eris, a Kuiper Belt object the size of Pluto. This discovery challenged the traditional definition of a planet, and Pluto was eventually reclassified as a dwarf planet at the International Astronomical Union (IAU) meeting in 2006 in Prague. A better view of the celestial bodies Eris, formerly known as 2003 UB313 and nicknamed Xena, is named after the Greek goddess of discord, reflecting the controversy over its classification. Mike Brown, whose work helped reorganize Pluto, earned him the nickname Pluto Killer on social media. Pluto's classification led to a revision of educational materials to reflect its new status as a dwarf planet. However, not all members of the scientific community embraced the IU definition. Some scientists in the world, especially those who focus on Pluto and similar bodies, expressed concern about the new criteria, which led to an ongoing scientific debate. These debates moved beyond scientific circles and into public discourse, raising questions about the usefulness of proper classification and the implications of renaming ancient astronomical terms. Despite these arguments, scientific research continued. In 2015, NASA's New Horizons spacecraft made a famous flyby of Pluto, revealing unprecedented views of this distant planet. The mission revealed an active planet with features such as a sugarcane field and a heart-shaped region that captured the imagination of the public. As we consider these developments, it becomes clear that our knowledge of the solar system is constantly evolving, making the naming of Pluto an important milestone in our continued exploration of the universe. As New Horizons travels through space at 32,300 miles per hour, it will capture images of Pluto's closest approach. However, due to the orbit of the spacecraft and the position of the Sun, the side of Pluto, known as the dark side, was still hidden. Analysts carefully examined images taken before the crash to understand this mysterious region. Despite the challenges of the limited scope of these images, the information is so valuable that scientists can see surface features up to kilometers across. This level of resolution is higher than previous observations from the Hubble Space Telescope. Analysis of these images has provided new insights into Pluto's dynamic nature, revealing features such as a subsurface ocean and surface processes. Recent discoveries, such as the presence of ammonia on Pluto's surface and amazing ice formations, continue to show the complexity of this distant planet. Richard Binzel, a cosmologist involved in the New Horizons project, calls Pluto the gift that keeps on giving because it continues to amaze scientists. Before the New Horizons project, the most detailed images of Pluto taken by the Hubble Space Telescope revealed the planet and its surface features. Still, New Horizons offers the necessary close-ups, including the impressive heart-shaped region and giant icy plain Sputnik Planitia. The discovery of Sputnik Planitia's unusual arrangement near Pluto's largest moon, Charon, has sparked interest in its creation. Some scientists suspect that the subsurface ocean influenced surface conditions. The presence of ammonia in the ice covering Sputnik Planitia indicates underground geological activity, indicating a dynamic and changing universe. As scientists continue to explore the data collected by New Horizons, they will discover more about Pluto's complex and evolving nature and expand opportunities for future research. The diverse terrain on Pluto's far side, including slopes, depressions, and fields, is similar to features found on other celestial bodies and planets. Deep sea. Although most of Pluto's orbit remains unclear, scientists await future missions to take a closer look. The anomalies found on the surface are fuel for speculation about Pluto's history and the location of its subsurface ocean. These findings challenge interpretations of the universe and emphasize the dynamic nature of distant planets such as Pluto. As New Horizons continues its mission, scientists speculate about the long-term fate of Pluto. Radioactive decay in the core can produce enough heat to damage the surface, causing wrinkles or fractures similar to those seen on Earth. But when New Horizons took pictures of the other side of Pluto, instead of broad strokes, cracks were found that indicate Pluto's surface has dried over time. There is a large rift in the vicinity of Pluto similar to Earth's East African Rift System, which may have resulted from the freezing and expansion of the subsurface ocean. According to the age of the eruption, the ocean cooled rapidly after reaching the surface, which may have created favorable conditions for the growth of life. In addition, the red color of Pluto's surface, indicating carbon particles, indicates the presence of complex carbon compounds. Laboratory experiments have shown that such particles can be created by radiation, such as the solar wind or atmospheric rays, which points to a possible habitation scenario on Pluto. The discovery of ammonia-bound ice near Pluto supports the idea that the dwarf planet may still contain organic compounds. While this doesn't mean it's life-saving, it's a sign that it can support life if the conditions are right. Measurements from the far side of Pluto have revealed surprising ground features, such as tall ice formations. As meta-ice, these structures are scattered around the equator and offer a great mystery. Concepts range from atmospheric cooling to solar energy absorption. Understanding the environment and the cold climate of Pluto requires a careful study of its atmospheric conditions. Researchers are refining weather models to better reproduce the observed anomalies and trying to recreate Pluto's atmosphere and surface conditions in a laboratory environment. Although the James Webb Space Telescope, JWST, can't take high-resolution images of Pluto, its ability to collect and analyze infrared light has made it possible to make additional observations. As we continue to unravel the mysteries of Pluto, humanity's insatiable thirst for knowledge keeps us moving forward. JWST represents a new era of space exploration, with advanced technology to study distant celestial bodies. Its ability to capture infrared light is essential for observing very faint or distant objects that cannot be seen in visible light, allowing scientists to study the early universe, the formation of stars and creation of the planet in the past. JWST's observations of the planet's atmospheres have provided important insights into their habitats, identifying atmospheric components such as water vapor and methane. One of the most exciting things about JWST is its ability to study the properties of stars, such as Oumuamua, a mysterious extraterrestrial visitor discovered in 2017. JWST's capabilities are expected to provide further insight into interstellar properties and provide important clues about planetary systems beyond our own. Pluto remains at the center of scientific observation as the representative of the Kuiper Belt. Data from the New Horizons mission revealed a lot of information about Pluto's surface and surface conditions. JWST observations can expand on these findings by providing additional data on the composition and dynamics of Pluto and other Kuiper Belt objects. Understanding these distant worlds is important in piecing together the history of the solar system and the formation of other planetary systems in the galaxy. As JWST continues its mission, it is poised to serve as a groundbreaking mission to advance our understanding of the universe. From studying the first galaxies to probing the atmospheres of exoplanets and interstellar visitors, JWST is set to make significant contributions to astronomy. As a result, JWST is at the forefront of astronomy, unlocking new mysteries and deepening our understanding of the universe, paving the way for future discoveries and expanding areas of human knowledge.